We are going to use geometric mean in situations like this where we have a right triangle and we have an altitude that divides that big right triangle into two smaller right triangles. So geometric mean is part of this, part of these special theorems. So first, just so we're all on the same page, if we have a right triangle like this, remember an altitude of a triangle goes through the vertex and is perpendicular to the side opposite of that vertex. So if C is the vertex that I've chosen in this triangle, then that makes CD an altitude because it goes through the vertex and it's perpendicular to that opposite side AB. So let's think of CD as our altitude. So CD is our altitude. Well, your altitude is going to divide that opposite side into two parts. So it's taking AB and it's dividing it into two pieces. So let's think of AD as the first part and then DB as the second part. So we're taking that whole leg, that whole hypotenuse of that triangle, and cutting it into the blue part and the green part. Okay, then we have three legs of our triangle. The longest side is the hypotenuse. Then this is one of our legs. AC is one of the legs. And CB is the other leg. So I have a leg, a hypotenuse. I have my altitude that is dividing that hypotenuse into two parts. So when we have an altitude that is going from the opposite vertex to the hypotenuse across to the hypotenuse, when the altitude goes from the vertex to the hypotenuse, we can find the length of the altitude by using this special rule. The length of the altitude, h, can be found by finding the geometric mean of those two parts. So the altitude is equal to the square root of parts times parts. So you're finding the geometric mean of those two parts, and that gives you the length of the altitude. So the altitude is equal to the geometric mean of, trying to switch the color, part times part. So you find the geometric mean of the two parts, and that gives you the length of the altitude. So if you are trying to find the length of one of the legs instead of the altitude, the rule is the length of the leg is equal to the geometric mean of the part that's closest to the leg and the whole length of the hypotenuse. So B, the leg B, would be equal to the geometric mean of part X and C, the whole thing. The length of leg A would be equal to the geometric mean of the part Y and the whole thing. So leg equals geometric mean of part and whole, or you can do the other leg and the geometric mean of the part that's closest to it and the whole. So X is the part that's closest to leg B. Y is the part that is closest to leg A. And again, these theorems apply only when your altitude is drawn from the vertex to the hypotenuse. From the vertex to the hypotenuse. Let's do an example. Okay, we want to find X, Y, and Z. So if I first want to find X, X is my altitude. So I'm going to use the first theorem, the altitude theorem. The altitude is the geometric mean of the two parts. So our altitude X is going to be the geometric mean of the two parts. The two parts are 5 and 20. So I'm going to multiply 5 and 20 and then take the square root of that product. So 5 times 20 is 100. And the square root of 100 is 10. So x is 10. Now let's find y. Y is one of our legs. Y is one of our legs. So the rule for finding the length of a leg is you're going to do the geometric mean of the part of the hypotenuse that's closest to that leg and the whole hypotenuse. There's my parents' grandfather clock. Do, 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 do. Do, 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 do. It's 3 o'clock. It'll chime 3 times. Sorry about that. Okay, we want to find the length of leg y. So we're going to do the geometric mean of the part that's closest to it, 5. And the whole thing. So the whole hypotenuse is 5 plus 20, which is 25. So I'm going to take the part that's closest to leg y, multiply it with the whole thing, and then take the square root. So this is just going to be, well, the square root of 25 is 5, and then that we have that 5 left over, so it's just 5 root 5. So y is 5 root 5. And then we want to find the length of leg z. So it's the same rule, part times whole, the geometric mean of part and whole. This time our part that's closest to z is 20, and the whole thing is 25. So I'm going to take the geometric mean of 20 and 25, the part and the whole thing. And 20 is 4 times 5. So the square root of 25 is 5, so we can take that 5 out. The square root of 4 is 2, so I can take the 2 out, and then I'm left over with this poor 5. He's not a perfect square, so this is just 10 root 5. So the final answer, x is 10, y is 5 root 5, and z is 10 root 5.